Peace. What's going on, tech and data nerds? By the end of this SQL tutorial, you'll be able to compile a complex window function of rank, and we'll be finding the top three most nutritious items per protein type. And this is our expected output. All right, so by the end of this tutorial, this is the complex window function that you'll be able to build by yourself from scratch. All right. Let's jump into how you're going to be able to achieve this. All right. Okay, so before we jump into any code, let's take a step back and let's just go over exactly what the rank over function is. Let's look at some pseudocode and just take this step by step. All right, so the business problem that we are solving for Gusto right now is to find the top three most nutritious item per protein type. All right. So this is a sample output that has some, like some test data in there, right? So this is what this might look like. So it'll help you guys visualize the SQL we need to create, right? So notice that we have grilled chicken three times because we want the top three. And then we have a sample title. So like, let's say there's grilled chicken bowl A, grilled chicken bowl B, grilled chicken bowl C. And notice there's the nutrition score and their rank. And the thing that I want to call out here is notice that when we go to tofu, tofu has its own number one, number two. All right, and number three, etc. All right, so this is a sample of what the output might look like. Let's start to jump into a definition. All right, so firstly, when and why should we use the rank and partition pie? All right, so when you're analyzing data, you're often going to need to find the top performing items within a specific category. All right, so here's some examples. Like in our case, we might want to find the top three nutritious meals, or the menu items per protein type. So that's the key here. Per protein type. That's where that partition comes in. It's a way of separating out the data and ranking it within a particular category. All right. Or you might want to find the top five selling products per store. You see that per store there? So for each store, what are the five top selling products, right? So let's say this was Starbucks, for example, right? So if we had Starbucks in three different locations, one of my favorite is the one off in 5 Points, and let's say there's another one that's down the street from in Peachtree off in Midtown, and let's say there's another one that's in downtown, right? And we want to know within each one of those stores, what are the five top selling products, right? So in the 5 Points location, what are its five top selling products? All right. At the one in Midtown, what are its five top selling products, right? And the one in downtown, what are its five top selling products? All right. Another example would be the highest scoring student in each class. All right. So again, let's say that you have your freshmen, let's say you have your sophomores, let's say you have your juniors and your seniors, and we want to know the highest scoring, or who has the highest GPA, but within each one of those. So the key here, let's go back to the top five selling products, is that each one of those store locations are going to have five top selling products. All right. So you might have one of my favorite, the Mid Majesty tea, and then you might have, another type of tea. You might have another kind of coffee, but each of those locations that I named are going to have five top selling products. All right. That's the key here. We're ranking a particular column and we're partitioning a particular column. All right. So this is where the rank function combined with partition becomes extremely useful. So instead of writing multiple queries, you know what I mean? So instead of writing a whole lot of different subqueries to get to this per group, we can instead, you can rank the rows inside each category in a single SQL statement. All right, so that's the when and the why. Let's go over just like a textbook definition of what the rank function is. All right, so you guys have probably heard this, and this is an advanced SQL topic. It's a window function. All right, so rank is a window function that assigns a rank number to each row based on the order you specify. If okay, this is a key takeaway here. So if you have two or more rows that have the same value, they receive the same rank, and the next rank is skipped. All right. So let's say, for example, that both chicken bowl and chicken bowl A and chicken wrap B. Let's say they both had the same ranking, right? Let's say they both had a 95. So what you would see here is a one, and then this would skip two and go to three. All right. We'll see another example soon. Okay. So let's go over the partition by. So that's the key here. The partition by clause divides the results into groups, all right, or partitions. The ranking function then starts over within each partition. Notice here that this goes one, two, three, right? That's our first partition or group, which is our protein type of grilled chicken. But then it starts all over again for tofu. Tofu has a one, two. You guys probably can't see the threes cut off. All right. So that is the partition. Those are the groups. Those are the categories, right? We want it to rank just within that category. What are the top ranking? All right. So that's the textbook definition. Let's get into some syntax for a second. So the most basic syntax of this is you have your rank, all right? You have your rank function being called, and then you have your over, right? And then you have the partition by, and then you have the column name, and then you have the order by, and then you have the column name, and then you can let it know whether you want this to be in ascending order or descending order. All right. So let's look at the explanation of the syntax. So the rank, right? This is calling the rank function, the ranking function here. The over tells SQL that this is a window function. All right. So we see our over. All right. And notice that everything in here is within this parentheses, right? So this is how SQL knows that this is a window function. All right. Partition by splits data into groups before the ranking. All right. So again, you can think of partition as group or categories. Like I want you to perform whatever you're going to perform within these particular categories, right? This is how I want you to separate or partition the data. All right. And then finally, we have our order by. So order by defines how rows are ranked within each group. So you have your highest score first or lowest, etc. Okay. All right, so now let's look at a high level example of the query we're going to create for our business intelligence question of the day, which is the top three most nutritious items per protein type. Okay, so we would select, so the items that are important to us, our protein type, our title, and our nutrition score. All right. And then let's look at our function. So we have our rank right here. So we have our rank being called, and then we have our over. All right. So then we know this is a window function. And then we have our partition by. So in this case, we are partitioning by the protein type. That is how we want our data grouped. All right. We want rankings. We want each type of protein, and we want to find the top three within a particular group, which is our protein type. All right. And then our order by. So in this case, as we're trying to find the top most nutritious menu items, we want to order by that nutrition score. And notice that we have descending here, right? We want descending because we want the highest nutrition scores to be ordered first. All right. As rank, and then we have from our food desert DB menu items. All right. Now, as of right now, we have not added in our where clause to limit this to the top three yet. This would simply give a ranking for each one of our menu items partitioned by the protein type, and this is going to be put in descending order for nutrition score. All right. So Just to give you guys a little bit more context on what just happened. So the partition by protein type, right? So let's look at this partition by protein type. Now this is, like I said, the simplified version. We know that in our real query, we're going to have to use case statements so that we can parse that title to actually give us the protein type. So this is the simplified version. You guys will see the real query in a second. So the partition by protein type groups items by protein. All right, so that's how we're grouping. So we're grouping either chicken or tofu or shrimp. All right, and then we have our order by. So the order by tells it how do you want these to be ranked? How do you want me to put these in order? What column do you want me to use to rank your information? In our case, we said we want it to be the nutrition score. All right. And notice it says descending. So within each group, it ranks the items from most to least nutritious. And then finally, we have our rank or RNK. It shows the number for each item inside its group. All right, let's look at the sample output here. Now, this looks just like the one up top again. All right, so we have our grilled chicken, that's our protein type, right? And now we have the ranking for each of the actual menu items that belong to grilled chicken. So we have we have chicken wrap A, we have chicken wrap B, and we have chicken wrap C. And notice that they're being assigned their ranking according to their nutrition score in descending order, right? So again, this is our dummy sample data. So again, let's say that chicken wrap A has a 95 nutrition score, chicken wrap B has a 90 nutrition score, and chicken wrap C has an 85. All right. Again, notice that tofu, right? It has its own separate ranking, right? And even so, again, you could tell this is being partitioned because its number one is a 92. You see how that 92 is less than this number one in grilled chicken? It's because it's irrelevant. It's not being compared to any of the grilled chicken types of menu items. It's only finding within the menu items that belong to tofu what are its top ranking food items. All right. All right, so now let's get into how do we get the top three. Now, this part is super simple. The only thing we're going to do is add in a where clause. All right, so now we have our same pseudo syntax here. All right, and then notice that we added in a where rank is less than or equal to 3. All right, and remember we got the name rank right here from our rank over function. All right, so we have our rank over, partition by, order by, and then we use an alias. So we call this entire section of code rank. All right, so now because this is in descending order, right, we have our 1, 2, 3. You see these 1, 2, 3. We can just say where rank is less than or equal to 3. All right, so now we're going to take a look at the SQL query that we're actually going to run in Postgre in a second. This time, you guys are going to see our case statements. Remember yesterday, we went over case statements in detail and all right, so that we could actually parse that title, right? Because that title has our protein type. So let's take a look, all right? You're going to see, I'm going to run this in Postgres in a second. All right, make this a little bit bigger for you guys. All right, and don't worry, I'm gonna run this again in Postgres. Okay, so let's look at what our actual query might look like. All right, so let me actually start within the sub query that's in our from clause. All right, so this is nothing different, guys. We have selecting everything from the table, and now we're creating a new calculated field that we're calling protein type. All right, you guys remember this? If this is not look familiar, make sure you guys go back and watch video number 1. Okay, so if we look at this, again, we have our case statement where we're parsing the title, right? So I like spicy chicken, then grilled spicy chicken, etc. And we're calling this the protein type, all right? So we've just now created a new calculated field, all right? So we're selecting everything from the table plus this new calculated field called protein type, all right? And also we're creating another calculated field, and this time it's the rank. All right, so now we have our function here. So we have our rank over partition by. Now, you guys notice, unlike the first query where we simply said rank partition by protein type, right? This column doesn't actually exist. So we have to run our case statement again, all right? So we're saying partition by, okay? And then we're doing our case statement. So this is still partitioning our data, but we have to spell out exactly how to get that protein type, all right? So and then we have our order by, again, guys, the nutrition score. That's our column. And then we're calling this entire thing rank. All right. So we've just now taken all of the data from our original menu items table plus these two new calculated fields. So the first calculated field that we talked about was protein type. That's here. And then we have another calculated field called rank. All right. And then we have our from food desert db dot menu items. And again, we are making sure that we're filtering for just our gusto menu items. That's why we have our Atlanta place ID equal to 2. Now, this is our subquery. We're calling this T. All right. So our subquery is what's performing all the logic that we need. And now within our outer query, we can simply call the columns that are of importance to us. All right. So imagine that. So you see how this is called a from, just like we have any other table. This is saying like, okay, this is where we're getting our columns from. All right. So instead of it just being a singular table, like, our nutrition score or our Atlanta place table, we created basically like imagine this being another like little like similar to a table. All right. So what we're saying is select the protein type. All right. Remember, we created that calculated field here. And then we have the title. All right. We still have access to the title because we selected all of the data from our menu items. And then we have the nutrition score. All right. Remember, we still have access to the nutrition score from our original table in the first place. All right. Now, notice that we are putting in our where rank is less than or equal to 3. All right, that's how we're filtering our data. And then we have order by protein type and rank. All right, just because we didn't select rank, it doesn't mean we don't have access to use that column. All right, so we're filtering our data so that we only get results that either have a 3 as their ranking or less. So that's 3, 2, and 1. All right. And then we have our order by. So we're going to order by our protein type and our rank. All right. So this is what our sample results are going to look like. All right. Again, it looks exactly like the first one. Now we're going to actually run this in Postgres so you guys can see the real results. All right. Okay, guys, so let's actually look at this data in Postgres. All right, so again, let's start with our inner query. So again, we're selecting everything from that table, and then we have our first new calculated field called protein type. Again, nothing new here. We have our case statements, and then again, we're in this as protein type. All right. And now we have our function that we went over today, which is our rank function. So we have rank over and then partition by. Again, we're going to do this with our case statements. And then we end this as rank. All right. And this mini in our inner query, again, we're getting this from our menu items and then where the Atlanta place food ID is equal to 2. All right. That's our inner query. All right. This is our from. This is where the data these are where these columns are coming from. All right. Now we're selecting the protein type. All right. This calculated field. We're selecting the title. Again, we still have access to that because we selected everything from our menu items table. So we're getting title. We have the nutrition score. All right. Again, we're getting this from our original data set. And then I also included rank here just so you guys can see what the actual ranking is. All right. So we have our select protein type, our title, and our nutrition score and our rank. All right. And We are adding in where rank is less than or equal to 3 because we want our top 3 performers. And then we're ordering by our protein type and our rank. Now, these are the results, but I'm going to run oh, sorry, this is the bonus one. So let me run this query so you guys can see the actual results. And there we go. So let's make this a little bit bigger for you guys. All right, so here we go. So, for example, we have our avocados, for example. Remember, that's the protein type. And here are our top 3 menu items by nutrition score. So we have our ginger, lime, peanut mixed greens, half avocado. We have our queso verde mixed green. And then we have our sweet soy sriracha mixed greens. All right. So those are the 3 highest in nutrition menu items for the protein type of avocado. All right, now for grilled chicken, all right, our 3 top nutritious food items are our queso verde mixed greens. We have our sweet soy sriracha, and we have our queso verde half and half. All right. For our spicy chicken, we have our queso verde mixed greens. We have our sweet soy sriracha mixed greens, and then we have our queso verde half and half. For shrimp, we have our queso verde mixed greens. We have our ginger lime peanut mixed green. Sorry, we have, oops, skip one. All right, so for shrimp, we have our tahini cucumber feta. Sorry about that. Mixed green grilled shrimp. Then we have our queso verde mixed green, and then we have our ginger lime peanut mixed green. So those are our 3 top nutritious food items for shrimp. And then finally for tofu, our 3 top nutritious menu items are the queso verde flatbread wrap. Number 2 is our Tahiti cucumber feta flatbread wrap. And then number 3 is our sweet soy sriracha. All right, guys, as promised, you guys are now able to write this complex function where we're able to find the top 3 nutritious items or menu items per protein type. Now, I actually added in a bonus for you guys. So let's say instead we wanted to find the top 3 lowest carb items per protein type. All right. Let's say we wanted to find for each protein type, what are the 3 menu items with the lowest carbs? All right. And to give you guys a hint, let's look at our original data set again. And I'm just gonna I ordered this by carb so you guys can have an idea of what this should look like. All right. So this is all of our menu items. All right. And notice that this time the column that we care about is our carbs. All right. So how would we find the menu items with the 3 menu items with the least amount of carbs per protein type? All right. This is going to be very similar to the first query we just created. All right. So let's scroll down and see how we would solve this. So this is our original data set. You guys want to pause this video for a second and just think through how would you actually do this for yourself. You guys are free to do that. All right, let's go into B. Now notice that this time we're selecting a protein type, the title, but this time we're selecting our carbs title. All right, sorry, our carbs column. All right, so we have the exact same case statement in here. All right, and we're ending this as our protein type. And now notice that when we do our rank over partition by, so we are still partitioning by the exact same logic. So we're still saying partition by basically our protein types. But notice this time we have an order by carbs underscore G, which is our carb column. And notice something else that's very different. We are saying do this in ascending order because we want to know what the lowest carb items are. All right. Since we want to know what the lowest carb items are, we want this to be put in ascending order. All right. Everything else is exactly the same, guys. And again, we're ordering by our protein type and our rank. All right. So let's run this query and look at the output. All right. So notice now for avocado, we have our menu items with our three menu items with the lowest carbs. So this time we have our queso verde mixed green, we have our ginger lime peanut mixed green, and we have our sweet soy sriracha mixed green. All right. And you guys can take a look at for each one of the protein types which menu item has the lowest carb, the top three with the lowest carb count. All right, so now I just want to show you guys so that if you're curious, like what if I just wanted the number one, right? What if I just wanted the top, like what is the lowest for each protein type, which menu item has the lowest carbs? So all I would do is go in here and change this to one. All right. And let's run this again. Okay. So notice now we only have one record for each protein type. So this is saying this is the menu item with the lowest amount of carbs for avocado. This is the menu item that has the lowest amount of carbs within our within the menu items that have grilled chicken. Same for our spicy chicken, same for our shrimp, same for our tofu. All right, guys, I hope you guys enjoyed this tutorial. Make sure you guys come back tomorrow. Tomorrow, the question we're going to go over is the lowest three nutrition score items per protein type. Now, you guys probably will be able to solve this by yourselves now. I want you guys to think through if you look at the first query, how will we change that so that instead of the top three most nutritious food items, instead, it were the oh sorry, it's a speed. So instead of the top three most nutritious items, if we wanted to find the lowest three nutrition items per protein type. All right, guys. So I hope you guys enjoyed this tutorial. Be sure to give it a thumbs up if this was helpful for you, and be sure to share. And if you guys would like to get, let me pause this for a second. Now, if you guys want to get this full cheat sheet, all you need to do is comment down below and I will get you guys this full cheat sheet. And if you guys want to get the full GitHub repo, plus you guys want to get that hands-on one-on-one mentorship so you can land the a six-figure tech job, all you guys have to do is request me on Fiverr. If you guys want the Fiverr link, again, all you guys have to do is comment below and I'll also put it in the description. All right. I'll see you guys tomorrow for our next full SQL walkthrough.